In a universe sprawling beyond our wildest imaginations, a silent yet terrifying phenomenon lurks in the shadows: black holes. These enigmatic giants evoke a sense of dread and wonder, capturing both the scientific community's fascination and the public's curiosity. So, what really happens inside these cosmic monsters, and how do they form? If you find yourself grappling with these very questions, you're not alone. Stay with me as we voyage into the depth of space and unravel the mysteries behind one of the most intriguing entities known to humanity. Let's begin with the big question: how do black holes actually form? Many of us might have a vague understanding that they come from dying stars, but the reality is far richer and deeply complex. Picture this: a massive star nearing the end of its life cycle. It's a beautiful spectacle, a celestial body shining as bright as a supernova, but this vibrant core has a secret: it's about to face a violent death. As the star burns through its nuclear fuel, it undergoes dramatic changes. The pressure in its core drops, and gravity, which had been counterbalancing the energy produced by nuclear fusion, begins to win. The once glorious star collapses inward, creating a gravitational pull so strong that not even light can escape from it. This marks the birth of a black hole. But that's just the beginning. Did you know that black holes come in different sizes? Beyond the single star's fate, we have stellar black holes, which form from the remnants of massive stars, and supermassive black holes, which can harbor the mass of millions to billions of suns at the center of galaxies. But how do these titanic entities come into existence? Here's something you didn't expect: while stellar black holes are birthed from stellar death, supermassive black holes are believed to have formed from the merging of smaller black holes over eons, or perhaps from primordial gas clouds collapsing under their own gravity in the early universe. Imagine that. Cosmic gatherings forming the largest structures in the universe. Each time we probe deeper into this topic, layers of mystery unfurl like petals of a cosmic flower. But I want you to hold that thought for a moment. Let's break down the life cycle of a massive star that ultimately gives birth to a black hole, because this phase is where the real magic happens. When you look up at the stars on a clear night, remember that each one has its story. Some will go out with a bang, while others will silently turn into astronomical enigmas. Initially, a star burns hydrogen in its core, fusing it into helium, providing the energy and outward pressure needed to counteract the crushing force of its own gravity. Eventually, the hydrogen supply dwindles. The equilibrium falters, gravity wins. As the core shrinks, temperatures rise, and helium fuses into heavier elements: carbon, oxygen, even iron. This stellar alchemy continues, but there's a catch. Iron does not yield energy when fused. When a massive star's core turns to iron, it's akin to a ticking time bomb. The core collapses, and in a final attempt to exert its dominance, the outer layers of the star collapse inwards, triggering a supernova, an astronomical explosion that outshines entire galaxies for a brief moment. But what remains once the dust settles? The remnants depend on the mass of the star. If the remaining core is more than approximately 3 solar masses, it can't hold against the gravitational collapse and instantly transforms into a black hole. This process is a stunning conclusion, the majestic yet terrifying chapter where star evolution meets gravitational dominion. So, where exactly does that leave us within the black hole itself? What marvels and mysteries lie behind that event horizon, the boundary beyond which nothing can return? You might be wondering, how can we truly know anything about something from which light cannot escape? Indeed, that's the fascinating twist. While direct observation is impossible, scientists infer black holes' existence and properties through their interaction with nearby matter and radiation. For instance, when a black hole devours material from a companion star or surrounding gas clouds, it emits X-rays and powerful jets. This cosmic feeding frenzy acts like breadcrumbs, leading us to the ultimate prize, an understanding of our universe's enigmatic dark side. Let's take a deep breath and consider the implications of actually entering a black hole. This journey is anything but straightforward. Once you cross the event horizon, the point of no return, you're no longer in our universe's realm of loss. The gravitational force escalates astronomically, spaghettifying everything in its path, pulling matter into elongated shapes. Yes, you heard that right, spaghettification. The term sounds ludicrous, but it effectively describes how intense gravitational gradients can stretch objects to extremes, elongating them like noodles. It's both whimsical and horrifying. And yet, as you approach the singularity at the black hole's core, an even more profound mystery unfolds. The singularity represents a point where gravitational forces are infinitely strong and space-time curves infinitely. Predictably, our traditional laws of physics, as we understand them, begin to fracture. What happens here? Here's something to ponder. Does time stand still? Einstein's theory of relativity suggests that time is intertwined with the fabric of space. Inside a black hole, this concept becomes warped. Imagine existing in a place where the passage of time is experienced entirely differently. Perhaps you might be taken aback by a concept like that. Does layer upon layer of complexity make you wonder about the limits of human understanding? Here's another fascinating twist. Quantum mechanics enters the fray here, too, teasing at ideas of information loss and what it means for our understanding of reality and the universe itself. This is where physicists wrestle with the implications of a black hole's existence. If information can disappear within a black hole, did it ever truly exist? Now, looking at it from a bigger scope, black holes also play an essential role in cosmic evolution. Their gravitational influence affects star formation and galaxy dynamics. In many ways, they are the engine driving the universe's structure. Yet, they also symbolize something far more profound, the limits of human knowledge. How does one reconcile the intersection of gravity and quantum mechanics found within the heart of a black hole? Speculation exists in the realms of string theory and loop quantum gravity, but we are still in the infancy of understanding. Even as we grapple with the profound existence of black holes in our universe, there are some staggering facts that can challenge your perception. Did you know that some scientists theorize that you could create a black hole in a high-energy environment, like those generated in particle accelerators? The world of quantum possibilities opens doorways into hypothetical situations where tiny black holes might be spun into existence and even evaporate away almost instantly. This leads us down paths of profound speculation and theoretical mind-bending possibilities. What if we could harness the power of a black hole? That sounds like science fiction, doesn't it? Yet, the tools of science often tread the fine line between what's possible and the imaginative realm of the impossible. This journey through the cosmos reveals not just the mechanics of black holes and their formation, but also the tantalizing idea that our universe is far more mysterious than we can comprehend. Is it any wonder then, as we explore the dark facets of existence, that black holes symbolize both the end of one's existence and the gateway to new realms of understanding? If black holes are the ultimate fate of massive stars, then it beckons the question, what exactly lies beyond? What follows this horizon? The mere thought leads to speculation about theories of parallel universes and wormholes, portals that might connect disparate realms of existence. One can't help but wonder, could black holes simply be passages to distant corners of the universe or even other dimensions? You might find it mind-blowing to contemplate that within these dark voids could lie the keys to understanding our position in the cosmos. As we inch closer to unraveling the complexities of what happens inside a black hole, keep in mind that each revelation brings fresh questions simmering beneath the surface of our understanding. The narrative remains unfinished, the story of black holes beckoning further exploration. So don't go anywhere just yet, we're just getting started. What we'll cover next will not only delve deeper into the theories surrounding black holes, but also explore how they foster an entire ecosystem of celestial phenomena. Stay tuned as we journey onward through the cosmic abyss, preparing for more revelations that will not only challenge your preconceptions, but perhaps inspire awe for the universe and our quest for knowledge itself. Keep your curiosity alive because, just around the bend, the wondrous and the mind-bending await. As we forge ahead into the cosmic abyss, let's revisit the array of phenomena that revolve around black holes. For many, the term black hole might conjure images of limitless darkness and inescapable gravity, but these entities are far from solitary. They form the heart of intricate celestial ecosystems. From the accretion disks that spin around them to the jets of particles ejected at near-light speed, black holes are dynamic players in the theater of the universe. The accretion disk is a swirling mass of gas, dust, and remnants from other celestial bodies that falls into the black hole's gravitational grasp. As this material spirals inwards, it heats up due to friction and powerful gravitational forces, producing an incredible amount of energy in the form of X-rays. This glowing halo serves as a beacon, allowing astronomers to detect black holes even when they are silent, providing critical insights into their behavior and properties. The beauty of a radiant accretion disk reveals the destructive yet creative nature of black holes, which can become some of the brightest objects in the universe, visible across vast cosmic distances. Moreover, the jets ejected from the poles of a black hole challenge our understanding of energy and momentum conservation. These jets can extend thousands of light years into space at breathtaking velocities, sometimes outshining entire galaxies in the process. The mechanisms behind these jets are still an area of active research, but theories suggest they originate from the incredibly energetic environment surrounding the black hole. Material falling into the black hole gets accelerated and compressed, causing magnetic fields to align and propel particles outward. Remarkably, these jets play a role in galaxy formation and evolution, influencing star birth in the surrounding regions and highlighting the interconnectedness of cosmic entities. Now, let's examine the dialectic relationship between black holes and galaxies. Supermassive black holes, lurking at the heart of nearly every galaxy, act as gravitational anchors, molding the galaxy's size, shape, and fate. Observational evidence supports the idea that the mass of the supermassive black hole correlates with the properties of the host galaxy. Larger black holes often reside in larger galaxies. This relationship hints at a coevolution where black holes and their galaxies shape each other's development over cosmic time. But what does this symbiotic relationship imply? It suggests that galaxies are not merely collections of stars and stellar remnants, they are intricate structures shaped by gravitational and energetic processes guided by black holes. Astronomers have begun to explore the idea that when galaxies collide, their supermassive black holes could merge, unleashing colossal energy events in the form of gravitational waves, ripples in spacetime first predicted by Einstein. Observatories like LIGO, Laser Interferometer Gravitational Wave Observatory, have opened a new window into this realm, allowing scientists to detect and study these cataclysmic mergers that echo through the very fabric of the universe. Now, let's pause and reflect on another intriguing aspect, the concept of Hawking radiation. Proposed by the theoretical physicist Stephen Hawking, this revolutionary idea suggests that quantum effects near the event horizon could allow for the gradual evaporation of black holes over eons. According to quantum theory, particle-antiparticle pairs constantly spring into existence and annihilate each other. Near the event horizon, one particle may escape while the other gets pulled into the black hole. The escaping particle constitutes Hawking radiation, leading to a gradual loss of mass by the black hole, a process that challenges the prior notion that nothing could escape a black hole. If black holes can emit radiation and potentially evaporate, this raises additional profound questions about their nature and the information contained within, leading us back to the earlier ponderings of whether information can be lost in a black hole. This dilemma has led to the famous black hole information paradox. If a black hole evaporates entirely, what happens to the information encoded in the matter that fell into it? This tug-of-war between quantum mechanics and general relativity continues to perplex physicists and serves as a compelling focal point in the search for a theory of quantum gravity. We now arrive at the tantalizing question: could black holes serve as gateways to other dimensions or even parallel universes? The allure of multiverse theories has captured the imagination of cosmologists. Some hypotheses propose that black holes could be bridges, connecting our universe to entirely separate realms. According to certain interpretations of quantum mechanics, the event horizon may not be an end but a transition into another space-time fabric. One particularly captivating idea revolves around wormholes, hypothetical passages that could warp space-time to create shortcuts between distant parts of the universe. Imagine traveling to a distant galaxy or even another universe within moments. While wormholes remain speculative and are fraught with contradictions, their potential existence fuels the dialogue surrounding black holes, suggesting that within these cosmic enigmas might lie avenues for exploration beyond the constraints of our known reality. Yet amid these grand theories lies a much more immediate question: what implications do black holes hold for our place in the universe? As humanity gazes into the cosmos, we encounter a vivid reminder that our existence is linked to processes far grander and vaster than ourselves. The life cycles of stars, the formation of black holes, and the evolution of galaxies are interwoven threads in the fabric of existence. Each discovery about these ancient giants not only expands our horizons in science but also rekindles a fundamental curiosity about life's place within the grand tapestry of the universe. In a world increasingly captivated by technology and the tangible, black holes remind us of the profound mysteries still lurking at the edges of human understanding. They evoke a sense of wonder which intertwines with our thirst for discovery. As new telescopes and observational technologies emerge, we inch closer to unveiling even more about these enigmatic entities, and with each revelation comes the promise of additional questions that provoke our imagination. Our journey through this cosmic landscape emphasizes the humbling reality: much of what we do not know vastly eclipses our current knowledge. The nature of black holes invites us to challenge the boundaries of our understanding, to ponder ideas once deemed science fiction, and to recognize that there is much yet to explore. As we prepare to conclude our odyssey, let us embrace the notion that black holes are not merely the ultimate endpoints in a star's life. They are vital components of the universe's cyclical evolution, transforming matter, shaping galaxies, and harboring mysteries that challenge our fundamental understanding of reality. They invigorate the realms of theoretical physics, inviting us to explore the boundaries between the known and the unknown, the tangible and the abstract. In closing, remember that the allure of black holes lies not only in their capacity for destruction but in their potential for creation and discovery. Whether they serve as cosmic beacons, gateways, or even clues about the fundamental nature of our universe, black holes call us to continue the voyage of inquiry and exploration. So, the next time you gaze at the night sky, allow your imagination to drift beyond the stars, into the dark ocean where black holes reside, waiting to reveal their secrets to those willing to venture forth and seek the extraordinary. The wonders of the cosmos await discovery, urging us onward into the timeless dance between understanding and the infinite unknown.